This is our crew patch. This was a breakfast that I'd long dreamt of attending, and here I got my chance, along with the rest of the crew. The red shift, you can tell who they are, had been up all night.
And this is the, you finally see the final scenes of the blue shift suiting up and the red shift coming up here. We got into our suits in plenty of time, and we were excited and getting ready to go to the pad. Next scene, you'll see us walking out, and this is about 5 o'clock in the morning, heading out for an 8 o'clock launch.
Well, we were sitting there looking at fairly blue skies, although we were able to see some clouds coming around. Eventually, after a slight delay, we got to go to launch, and then things started getting busy for us inside. Right about this point right here, we knew we were going somewhere. Just pretty incredible the way the vehicle leaps off the pad, begins accelerating, and doesn't stop for almost 8.5 minutes.
Go from 0 to a little over 17,000 miles an hour in 8.5 minutes, and when you divide those two numbers out and realize you're accelerating about 2,000 miles per hour per minute, it makes sense that you feel the strength of push that you do in the back of your seat. And superimposed on that is a little bit of an earthquake from the solid rocket motors. It's a pretty impressive ride.
One of the things that was impressive to me from the standpoint of the other crew members was we had a running dialogue going. Brian was kind of calling out Mach numbers and altitude, and I would try to throw in something every once in a while. But in checking with the folk down on the middeck, everybody seemed to be quite aware of what was going on, and that was a comforting feeling, you know, as a commander, to know that everybody was alert and ready to get going.
The boosters came off right here, and that was, of course, accompanied by a nice flash of fire from the booster separation motors across the windows. We got a little bit of glazing on the windows at that point. Eventually it ended up burning off during the entry, however, so it was never a factor.
Shortly after MECO, we had external tank separation, and we were able to get some pictures of it, and that's a picture of our external tank after it left us.
The challenge of the blue shift was to quickly jump out of the suits and grab some clothes and the books that we needed to begin operating, and by about 2 hours after liftoff, be up on the flight deck with the doors open and ready to power up the laboratory and all of the experiments. This is a scene of payload bay door opening, which is about an hour and a half into the flight. It was already pretty clear, I think, to all of us that Atlantis had a high probability of just being a superb platform for our work for 9 days, because this had gone far more gracefully than you ever see it in any of your training, and really gives you a comfortable feel for starting a busy flight plan. We turned to right away and had the lab powered up in short order, and you see the typical view that we looked at out the payload bay windows here, with the black balls on their platforms, which are the charge collecting devices that CPAC used to provide a return path for electrical current.
This is where the orbiter crew did most of the work up on the forward deck. We're getting right here. We're finishing up our flight control system checkout before reentry.
And over 220 maneuvers to accomplish over 9 days to make sure all the experiments were pointed in the right directions.
The space lab operation of the payloads were done from the aft flight deck, and mostly in the dark. That's why we don't have a lot of pictures of it, because it was during the nighttime. Like here, this API came alive, like I was saying, it was getting out of the locks and pointing then to an aurora, or to the try to find artificial aurora. So it was always exciting to see these experiments actively working. It is pointing up.
Okay, this is the scene of the Aurora. The Earth's up, as you see it on the screen there, and you can see the three little turrets of the API camera. I want you to, as you zoom in here, look to the middle left, and you'll see a meteorite go by, actually above us in the picture here, but it's below us as far as the Earth goes. The Aurora, of course, are generated by, it's coming up now. There you go, yeah, you saw it. The Aurora are generated by protons coming from the sun, spiraling down the field lines.
Here's the electron beam coming out just a little right of center, and superimposed on that is the results from the API camera. You can see a little glow to the left of center about every 15 seconds. We're going to cut back and forth. Here's another beam firing.
And then you see the glow that you see in the middle is the natural aurora, and in the middle of that you can see the spot from the beam, and that is really the first time that this has been done in space and that we have been able to watch it with a camera. So
that beam really did look like one of the phasers that is in Star Wars or Star Trek. It's really an amazing phenomenon to see this come out of the orbiter for the first time.
In addition to the electronic detector that the API experiment involved, the investigator also had supplied us with a fairly complex set of photographic cameras and optical equipment. And you see me here on one of those tests. Often the target was the same as what the detector was looking at, but we could use different filters or other optical elements to get complementary data. Again, this one was photographed to show you what we were doing when the lights were up a little bit. Normally this was done by feel and by memory of the procedure in the dark as the target went sliding by.
Everybody has something that they call their favorite when you go fly, and mine is lightning, because I always tell everybody that to me it's like an orchestra playing, and lightning plays off each strike. You know, you'll see one and it just ripples all across the face of the earth. It's a beautiful spectacle. You can actually see the earth limb in the upper left-hand corner there, and the big city, or the bright spot you see that's steady there, is the city of Buenos Aires. As we're coming up on an ascending orbit here, and we're actually going up along out over the Atlantic Ocean off the east coast of South America.
This is the sunrise, the picture that you have with the different colors, so that from red to blue. Sometimes it's really you see nearly all the colors and the different layers. There are quite a number of layers. And some of these colors are produced by the dust that is in the atmosphere. So it's since the eruption of the Pinatubo, we have quite some dust, and this adds to the red glow that we see in space.
This is the redshift going to work in the morning. As we put new meaning into tumbling out to go to work in the morning, tumbling out of bed. But that's the bunks that we used, and they work very well to give us a good night's sleep while the other shift was up working. Of course, we have to have our actors on board, and it's...
It was tiresome work sleeping all night in those bunks.
Brian had mentioned earlier that we were going to show you some of the mundane types of things that go on, and so for the next few seconds here you'll get to see us as we prepare food. We did a number of things that you would not necessarily think are done on a spaceship, but you've got to eat, and that means that somebody's got to go to the kitchen. That's our water dispenser and an oven that every once in a while you'll see Kathy open the door here and stick food in. The foods were very, very tasty. Very, very filling, although you wondered that because we seem to be eating all the time. We really enjoyed the food and drink, and so that's kind of one of the things that's going on here. In addition to this, something you won't see, we had to clean filters. You had to dust and mop, and we'll show you a little picture of us swabbing, as I call it, later on. Here Dave's eating one of the favorites of almost all the crews, and that's shrimp cocktail. So you get a chance to see some of the better food there. And it behaves much better than it does down here. Gives you an opportunity to think about it. Here we were doing some of, another one of the more fun things to do is decide how you would like to have your M&Ms. You just turn them free and then you go get them. And kids always have a very good time with this. They can imagine being there. And I'll do a reverse slam dunk here in a second and gobble up one.
One of the secondary experiments we had on board was the SARX, or the Shuttle Amateur Radio Experiment. Here you see Dave talking to someone. I don't remember. Do you remember where you were, Dave, doing that?
I think I was talking to a school, and you'll see the concentration trying to listen to the kids' questions here in a minute, and then be able to make answers. It was kind of fun to talk to auditoriums full of school kids while you're flying right over the top of them.
3 of our crew members, Dave, Kathy, and Brian, talked to all 7 continents during our 9 days in space.
Well, here you see our commander keeping fit for the entry, and I'm really glad he did that because he did an excellent job. Charlie was doing a DSO for 30 minutes every day running, which he sometimes enjoyed, but maybe not. Of course, I had a different approach to what you should do with a treadmill. Here you see them changing LiO out. Basically, the treadmill was mounted across those holes in the floor of the middeck, where we keep the lithium hydroxide, extract the carbon dioxide that we exhale. during the day. Of course, we do that once every shift. And then when we do that, we do it rather carefully. We have to put it into these little cellophane packets to make sure that the debris from the canister, which can be toxic, doesn't get into our atmosphere.
And then you saw what I was doing with the treadmill. I got a lesson in what physicists do with treadmills, and you will get an opportunity to see it come into view here. Dr. Foale was real big on moments of inertia and getting an opportunity to try different things and see if he could display varying moments of inertia of different components that we had on board.
You see, I've been told to hang on the ceiling and just be quiet and out of the way and hold the treadmill. So what else was I going to do with it?
The crew vote was that Mike's version of exercise was far preferable.
One of the things you have to worry about is with 7 people, you generate a lot of trash. And we have a trash monster down here, and we had to be careful when we fed him every day that we didn't get caught. You didn't want to let him get you, because then you get pulled down below the middeck, and that's a bad place to be on one.
One of the things I learned a long time ago when we started training was that I had 2 rabid golfers on board. I would say avid if I counted Byron in, but Byron is not quite rabid like Dave and Brian. But this is the 44th hole at the Atlantis Golf Club, and I'll let them describe it to you.
Well, teeing it up is pretty easy.
Never falls off the tee.
Never falls off the tee.
Now, watch this carefully, because this is the longest drive in history. That's about 15 miles right there in about 3 seconds. That's how far that ball went. Now, lining up putts is very difficult, and Brian, he had a good idea here, except he was lining it up from the wrong attitude. So we had to correct that and figure out. Of course, neither he and I could really get it lined up properly, and it took Byron to hit it in here in a minute.
David remembered that we were not flying level but inverted here, so he took the opposite approach.
That's right. These 2 guys gave me a good reading, and as typical caddies, you know, one says break down and right, the other says break up and left. So when I get up here, I just kind of tried to hit it towards the hole, and voila. The 45th hole.
We were fortunate in having 3 Academy graduates on board, 2 from the United States Naval Academy and 1 from the U.S. Air Force Academy, and we happened to have a United States Military Academy graduate as a Capcom for several of our shifts. So we sent this visual message to Sam Gaymar while he was down there, just in love.
Charlie was really good at documenting what other people were doing, but we were a little lax in getting him, so we finally tried to find him commanding. So this is a view of what Charlie does when he's commanding.
You see what the crew is doing.
Yeah.
Now.
Meanwhile, down below, Charlie said something about why don't you Brian, you take your shift downstairs and swab the decks, and I didn't know what that meant because I'm not in the Navy, so he had to explain it.
But we found out on Blue Shift very quickly what that meant as we moistened up washcloths and went all over every surface we could find to, as Charlie said before, neaten the ship up and return it in proper form to the folks that had given us such a good spacecraft.
And even I was employed for that. It is something they have never told them before, that they have to do that on board. And I never got any training for it either.
Well, finally, after 9 days, it was time to come home. And I must say, I really wasn't ready to do so, and I don't think anyone else was. We were very, very comfortable on orbit. We'd had a very successful mission. We had a good routine, and we were enjoying ourselves immensely. And this is really the beginning of the end of our glorious flight.
This is the plasma going out the back end of the orbiter, and it was really pretty impressive as Kathy and I took some pictures back out the overhead. And then we took them back out forward, and you can see the reflections of that on both Brian and Charlie as we're going through entry. It is totally dark outside, by the way.
The camcorder can't really do this justice, in particular the colors, which are all sorts of shades of salmon and pink and orange. They really do look somewhat like the inside of a blast furnace. You may notice the horizontal streaks or small blips of light through the scene. Those are electronic noise that are created in the camcorder because of all the electrical energy that's involved in the process that you see outside lighting up the sky.
Once the light show was over, we got in. We flew into daylight somewhere around Mach 6 or so, approaching the Cape, and we turned onto the hack. We had some pretty good winds, which made it a healthy turn for us. And I got it around about halfway, and Charlie picked it up. And
when I took over from Brian, we basically on board, we have guidance that we follow that tells us whether things are good or bad. And I mentioned to the guys in the office this morning, by the time we got ready to roll out on final, everything looked like it was good, because we go to another landing aid that's called a microwave landing system, and it gets you, real fine lineup. And the orbiter, again, was amazing, because when we fly our simulators, you always see things jump around when you get the MLS as you're getting to the final fine guidance and everything. But on the orbiter, it did not move at all. So we were right where we wanted to be. Basically, what I did was get everything set up during what we call the outer glide slope portion of the approach, and then make a final adjustment just before the touchdown, about the 30 or 40 foot point, and let the orbiter land itself. And it's an amazingly stable vehicle. It flies very, very well. It flies better than any simulator that I've ever had the opportunity to fly. So there was nothing surprising about its performance at all, unless you want to say that it performed a lot better than I thought it was, and it handled a lot better than I thought it was going to be. That was it, kind of the end of the flight.